Welcome to Learnpedia, the ultimate JEE and NEET prep tool that is currently being used by over 20,000 aspirants. Now let's see if you can answer this actual NEET question. If you think you got the answer, then post it in the comment section below. To understand the concept behind this question, go ahead and watch this video.
We will discuss about the magnetic flux. What do you mean by magnetic flux? We know the magnetic lines of forces. Suppose in a certain region, the magnetic lines of forces are given like this. Magnetic field here is B. We can choose any area. Through this area, how many lines are passing through? That gives us the magnetic flux. The magnetic flux is the total number of magnetic lines of forces passing normally through an area placed in a magnetic field. It is equal to the magnetic flux linked with that area. So if I choose this as area, this is the length, this is the breadth, area vector directed in this direction, let me call this as dA. Here the magnetic field direction is given as B, making an angle theta. Then the magnetic lines of forces passing normally through this area gives us the flux. So we can write here the total number of magnetic lines of forces passing normally through an area placed in a magnetic field is equal to the magnetic flux linked with that area. So the net flux linked with the surface can be given by net flux through the surface. We can write as phi. Phi is equal to integration for a closed surface magnetic field vector dot area vector, or it can also be written as BA cos theta. Theta is the angle between area vector and the magnetic field vector. Remember, if theta is equal to 0 degree, then the flux will be B into A cos 0. Cos 0 is 1. That means the magnetic field is normal to the area vector, then the flux is maximum. And if theta is equal to 90 degrees, that means the magnetic field is in this direction, whereas the area vector in this direction. Then in that condition, the flux phi will be equal to 0. So the flux is phi is equal to integration B dot dA. It's a dot product of magnetic field and area vector. So if the magnetic field is in the direction of area vector, then in that condition maximum flux through this area. If magnetic field is perpendicular to area cross section, then the net flux will be 0. Magnetic flux is a scalar quantity. It is dot product of two vector quantities. Magnetic flux is a scalar quantity. Its SI unit is Weber. It's given as WB. Series unit is Maxwell. 1 Weber is equal to 10 to the power of 8 Maxwell. We have other units also. Because it is B dot A, we can also write 1 Weber is equal to Tesla into meter square, which also can be written as Newton meter by ampere. That is equal to also Joule by ampere. So we can write in different forms: volt into Coulomb by ampere, or equal to volt second, or Ohm into Coulomb, or Henry into ampere. Dimensional formula of phi, it's equal to ml square t to the power minus 2 a to the power minus 1, a for current, ml square t to the power minus 2 a to the power minus 1. So flux associated with any imaginary area is the dot product of magnetic field and the area vector. The total number of magnetic field lines of forces passing normally through an area placed in a magnetic field is equal to magnetic flux linked with that area.
Hey there, hope you understood the concept. Here is the solution to the question asked at the beginning. Found this video useful? Hit the like and share buttons to enjoy more such videos. LearnPedia's JEE and NEET prep tools contain over 4,000 videos and 20,000 solved examples. They are accessible online on our website and also offline through SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of our product on our website.